g of x approaches, now I look at the second equation. It's negative square root. Instead of x, I put negative 3 plus 3 minus 4. And what do I get there? Negative 4, which is the same thing I got here. Now, in f of x and g of x, both of these, notice they're different numbers that they're approaching. So since they're approaching different numbers, that's why it's a jump discontinuity. So that's how you can tell without ever looking at a picture. If you plug in numbers to the top and the bottom and they're not the same, then you know it's going to be a jump discontinuity because there's a space between those. Yes, sir?
Can I use the restroom?
You may. Grab a pass, make sure you sign out. And when you come back, make sure you hang that pass on the pencil sharpener, yeah. Okay, so moving on. Now we're going to look at h of x. So h of x is this equation and this picture. That's h of x. So what type of discontinuity was h of x? Point, and where at? Yeah, x equals negative 1. Please let me know if you're not seeing how we got either one of those or one of them. That's important. Those are supposed to be the easy points, so if you miss that, it'll be real easy to explain to you. Okay. Then we got to figure out if it's defined. Is there a value for h of negative 1? Yes, what is it? What is it? 1. Okay. Is it?
No.
No. If it was 1, what would happen here?
The big close.
I'd have a dot. Yep. So it is undefined. And we can also tell that because both of these are not or equal to. One is just less than, one is greater than. So there's no value for negative 1. Good. Okay, so what numbers do I fill in these blanks with?
Negative 1.
That is right. And this time, as x approaches negative 1 from the left, so we're going to look at the graph. Yeah, fill those in. Look back at the graph, look at x approaching negative 1 from the left. I got those in. And x approaches negative 1 from the right. And fill in those two blanks. Donna, what did you get for the first one? So as I approach it from the left, what's the y getting close to?
1.
It is 1, yes. See, because as I approach it with that yellow line, the y value is 1. So Donna, as I approach it from the right, so as I go from this side, what's the y value? 1, same thing, yep. Good job. How?
It doesn't matter that it's an open circle.
Does it matter?
How come it doesn't matter?
Well, it does matter because that's what means it's got a point discontinuity. It means it's not continuous. There is no value. That's what tells us that it's undefined. And the reason why it's okay to put 1 here is because that is not saying equals 1. That arrow just says approaches 1. Good question. Okay, so now we do the same thing but with the equations. So as x approaches 1 from the left, we use the top equation. H of x approaches, find that equation somewhere, absolute value of x, which is -1, plus 4, and then minus 2. Notice that is 1. Yes. Sorry, I left out the little negative. Thank you. You are absolutely right. And then on the next one, yes, as x approaches -1 from the right, h of x is going to be the second equation. And that's -x minus 1. So x is -1 squared plus 5. So it's -2 squared, which is 4. But then there's a negative in front of it. So -4 plus 5 is also 1. So now this one is a point discontinuity, not a jump. Why? Yeah. Because those two are the same. There's still an open hole there, but they met. Take a couple of minutes and fill in as much as you can on P of x. Questions? Stop. Stop. start going over this. What type of discontinuity would it be, Becca? Point. And it's at x equals negative 3. Okay. All right. Then, is it defined at this value, Justin? Yeah. What does it equal at negative 3? Negative 2. Very good. Yeah. It equals negative 2 because that's this point. Now I have an open circle up here, but it's not equal to that point. So it actually equals negative. There it is. Negative 2. Excellent.